Hi, for this recording, I'm going to show you an application of the mean value theorem. Let g be a real function, be continuous on a closed interval from 3 to 5, and differentiable on the open interval from 3 to 5, and g of 3 is equal to 3, such that g prime of x is between minus 1 and 2 for all x between 3 to 5. Now our aim is to use a mean value theorem to prove that g of 5 between 1 to 7. Our aim. Okay, to do this, we must make use of mean value theorem, so you must understand the statement of mean value theorem. Let's look at the statement of mean value theorem. Okay, so the statement of mean value theorem says that if you have function f continuous on a closed interval from a to b and differentiable on the open interval from a to b, then there is a point c on the open interval from a to b such that f prime of c is equal to fb minus fa over b minus a. Okay, this is the statement of mean value theorem. And what does this mean value theorem actually says? So let's draw a picture of telling you what does the mean value theorem trying to say. Okay, now we know that if you have a open interval from if you have a closed interval from a to b, the mean value theorem says that say a to b, and say a function is continuous on a closed interval from a to b and differentiable on open interval from a to b. Alright, then let's say this is f of b, this is f of a in terms of y. Then the mean value theorem says that I must be able to find a c somewhere along in the interval such that if you join the straight line ending this endpoint, then you must be able to find a c such that, for example, c could be here. The tangent line to c is parallel to the second line joining the endpoint. Alright, so f prime c is equal to fb minus fa over b minus a. This is the statement of the mean value theorem. So since our function given g is continuous on the closed interval from a to b from 3 to 5, is differentiable from open interval on the interval from 3 to 5. So apply all the conditions the mean value theorem are satisfied. So apply the theorem, so there is a point c between 3 to 5 such that g5 minus gt over 5 minus 3 g prime of c. Now we know that g3 is equal to, based on the question, g3 is equal to 3. So you make use of that. So g3 is equal to 3. And this is equal to g prime c, where c is between 3 to 5. Now we are also given that g prime c is between minus 1 and 2. Therefore, g5 minus 3 over 2 is between minus 1 and 2. Now multiply both sides by 2. Inequality will give you minus 2 less than or equal to g5 minus 3 less than or equal to 4. Then add the 3 both sides. So 3 minus 2 is 1. 3 plus 4 is 7. That's how you get g5 between 1 to 7. This is how you show this solution, by using the mean value theorem. Okay, so let's look at the solution. Again, this is how we present. That is the end of this recording.